This was due today, right? All right. Can I sit here today? Kevin sticks his finger in his mouth and then sticks it in my ear. Gives me a wet willy.
Yeah,
it's no fun. All right. So let's see how we did with these. Okay. Remember, we're doing substitution. So hey, let me ask you this though before we start. Graphing is a pretty good tool. Agree?
agreed.
But graphing sometimes can be tougher to do, especially when we have decimals or fractions as intercepts or points, or where they cross could be way off the graph, or where they cross could be at fractional amounts. Agree? So when we do graphing will really only work in this class if we can graph between -10 and +10 on the xy axis, and our graphs cross at exact whole numbers on the xy axis. And I will tell you that, especially when you deal with real life situations, when you're applying mathematics, doing regression equations, or you're doing extrapolation or interpolation, graphing is a nice tool. It's something visually nice because you're seeing it, but it's not really how most things take place. So let's take a look at problem number 1. And again, please make any adjustments to yours. All right, so we have these two equations for problem number 1. And I helped quite a few of you start this problem originally, and once you saw how it happened, it made a whole lot of sense. So I know that y is equal to x plus 1. I also know that y is equal to 2x minus 1. Agree?
Agreed.
All right, so that just means that I could take this and set it equal to this. Okay, is that pretty straightforward? And the reason why we can do that is because y is equal to both on each. Oh, cool, come sitting by us. Love it. All right, so I need to start solving this. So I want to get x by itself. So what seems like a good idea?
-1 from each side.
Okay, -1 from each side. We had to start someplace, so it seems fine. Now you might have chosen a different route on that, and you're still going to get the correct answer as long as your arithmetic's correct. Then I want x by itself. So you remember that's a 1x. That cancels. That gives me -x equals -2. So if -x equals -2, what does x have to equal? 2. All right, so first part of my answer is 2, comma, I don't know the y value yet. Agree? Agree? All right, so my friends, I have a choice to make. The nice thing is the choice will result in the same answer. So I'm going to take 2 and replace it with x. Which one of those equations looks easier to solve for x? The first one or the second one? The first one, yeah. Okay? It doesn't matter which one you plug it into, but sometimes if you're working smarter, you're saving time. So I'm going to take this 2, I'm going to plug it in right there. So what's y equal to? 3. Done.
Okay.
Pretty straightforward, yeah? Okay.
There's very few of those. I'm saying, that's why I can know, but bro, what did you do?
This has happened so many times.
Oh my gosh, thank you, Genius.
Every now and then a blind squirrel finds a nut.
How did you do it? How?
I got lucky.
No. Magic.
All right. Moving on to problem number 2. Ooh. You know what? Ew. You know what? I'm going to skip number 2. It's a misprint. We had y on both sides. Let's just skip it. Okay?
2 was a misprint? I knew it. Because that's why I couldn't solve it.
So I'm skipping number 2, okay? I'm sorry. We make errors in the book. We don't mean to. It might happen. All right. So, problem number 3. So we skipped number 2 because it wasn't the prettiest. Agree? All right. So we want to do substitution on this one. Agreed? What we want to realize is x is equal to this. That's what x is equal to. So I'm going to replace this x. I'm going to put that in for it. Does that make sense? All right, now we got to work smarter on this one. So I'm going to get 1/2 y plus 2 minus y equals 1. All right, so let's see who can recall something from like 11 weeks back. What can I do to get rid of the fraction?
Multiply it.
Exactly. Right? Remember, we're working smarter, we're saving time. Saving time means more time on your phone. So let's multiply everything by 2. And when I do that, this cancels, and that just leaves me y. This gives me plus 4, and this gives me minus 2y, and this gives me 2 times 1, which is 2. Okay? Do we feel comfortable so far? That looks a little nicer. We don't have to deal with the F word any longer. Fractions. All right, so I'm going to combine these together. So that's 1y minus 2y, which is negative 1y or negative y. And then solve the rest of this. So negative y equals negative 2. So what does y have to equal? Positive 2. So we found the second part of our answer. We found that to be 2. Okay? All right. So what I want to do is I want to take this 2 here, and I want to replace it either here or here. Okay? Now, we could shy away from the fraction. That's okay. But we also logically could say, I'm looking for an x value. The second equation is the x equals already. Can we take half of 2? Yeah, we totally can. So if I plug it into this equation, hey, what's half of 2, friends? 1. So we get 3. There's my answer. Okay? We would have gotten the exact same answer if I had plugged it into the other equation. Okay? All right. Friends, may I move on to number 4? Are you taking appropriate notes if you needed to? Okay. All right, so problem number 4, we have x equals 3y minus 27. And then we have 2y plus 5x is equal to 35. Okay, this one looks like it's got a little extra horsepower to it, but I think we're okay. Do I know one of the letters? Is one of the letters all by itself on one side on one of the equations? Yeah, the first equation, we know that x is equal to something, right? We know that x is equal to this. So I'm going to take this, and in my other equation, I'm going to replace that x. So I'm going to 2y plus 5 parentheses equals 35. Where those parentheses are on the green is where x used to be, but I'm going to replace x with what I found that it's equal to. It's equal to this. Okay? You see how I just slipped right in there?
Yeah.
Looks like a little distributive property is going to take place here. So I get 2y plus 15y It's negative. Let's see, 5 times 27. 5 times 7 is 35. Carry the 3. 5 times 2 is 10. 10 plus 3 is 135. Equals 35.
A lot of writing.
Okay. Well, sometimes we just have to do the puzzle. That's really what it is. All right. These are like terms. That gives me 17y. Now, a lot of people might shy away from doing this problem because they're like, dude, I got 135. Okay, maybe it'll come out nice. I don't know. Let's see. Add 135. Agree?
Yeah.
So 17y equals 170. Oh, I think this is going to work out nice. This is going to work out real nice. Agree?
Yes.
What does that come out to?
10.
10. Oh, that's a nice answer.
That's really nice.
So I get a 10 right there. Agree?
Yes. Oh yeah.
Okay. Yeah, we're going to plug that back in. Good job. So I'm going to take this 10, which is a y value, and I'm going to plug it in either here or here. It doesn't matter which one I pick. It's going to get me the same answer on both. Agree? And shoot, all we're doing is multiplying by 10. We learned how to do that. Times 10 was first favorite, or actually second favorite because times 1 was first favorite. All right, so I'm going to plug into right here. So I get x equals 3. This was a y. What's going to go in there? 10. 3 times 10, I believe, is 30. 30 subtract 27. Yeah, but the numbers are so big. Oh, sorry, you get 3 comma 10. That's the answer. That's the solution.
Oh yeah, baby.
So friends, I kid you not, I told you this originally when we started this stuff. This thought process of getting the ordered pair is a very similar type of iteration that your phone uses when you either have to do the facial recognition or type in your code or your fingerprint, however you get your phone unlocked. This is the thought process that goes behind it. Basically, when it takes a picture of your face on your phone, it finds the geometry of your face, and then it says the geometry of your face is equal to 3 comma 10, or something like that. And then it plugs that 3 comma 10 back in and says, dude, it's a solution. You're in your phone. Now, it does it a lot faster than we work out because it's working at 0.1 the speed of light. Okay, that's how fast electricity goes.
Okay.
Okay.
Don't you have like an iPhone 6 though?
Yeah, so it don't recognize me. It's an iPhone 4. Get it right.
Also, too, a lot of
Hey,
these
the
don't
youngest
have-
on my own.
Okay, hold on. Raise your hand. Raise your hand if you like Disney. Raise your hand if you like Pixar. So, like for example, Pixar had a museum. They actually had an exhibit at the museum, and they actually went through. So Pixar, for them to design like the characters, you have to draw them, but for them to move, for them to have specific hair, for them to have like specific features, they have to use actually algebraic equations. They have to use type of equations like this. Not exactly, but very, very similar to this. And so if you are like a type of person who loves design, loves doing like cartoons, is thinking about going into that world, you will be actually using algebra to create that in actually Pixar. So that's something, I don't know, that's why when you said phone recognition, I was like, they also did that for Pixar.
Heck yeah.
And they have to create their own equations too, to create specific type of hair, specific type of eye color. Just saying.
Do you guys know there's an equation that looks like this? There is an equation that looks like this. There's an equation that looks like this. If you could solve this equation showing where n is greater than or equal to 5, and you solve x, y, and z are whole numbers. If you can solve this equation, the German government will pay you $17 million.
Can you solve it?
No.
You tried?
Yeah.
Can you search it up on
You
YouTube?
just solved it.
No, I didn't solve it. No, because I want to know what x and y and Z equal.
I'm about to search it up on YouTube, and I'm about to about 17 million. Honestly, YouTube is statutory, right?
But then you never cancel out because Y and Z are not the same.
So where you've seen this equation in a lesser form?
So there's no like number.
No, there is a solution. So this is called Fermat's theorem.
Yeah.
Okay? Fermat was designing this, and America had brought him over from Germany, and during World War II.
Oh yeah, because he was like a German scientist.
And Fermat, in his notes, before he died, in his notes says he has Fermat's theorem, has that, and he has in the little side area of the booklet, I have solved this equation in another notebook. Yeah, we need to start digging this guy up. So friends, where you've seen a lower degree of this, have you ever done the Pythagorean theorem?
Yes.
The Pythagorean theorem, the n values are all 2, right? Okay? So he is able to solve this for where n is greater than or equal to 5. No.
Can we YouTube it?
You solve it, you get 7.
You can show the mathematical proof to solve it.
Why
17 million.
Wait.
This is actually one of the big deciphers to unlock encrypted computers at the highest government level.
Oh, so the
Wait, what's the
FBI knows
answer?
this.
What's the answer?
I don't know.
Does the FBI know how to do this?
It has not been solved.
Yeah, Illuminati has. This has been solved before. It has to be.
Fermat solved it.
No,
We haven't.
there's got to be a YouTube.
What if I had to ask
There has to be. Instead of you on my phone and search it up on YouTube, there has to be one out there.
Hasn't been solved as far as I know. It might have been solved, but I don't know.
All right, sir, but you're gonna go find this book,
All right. So
Side note.
what we're going to do is we're going to go back to solving when x and y are raised to the first power. But I'm showing you math that could make you a millionaire if you solve Fermat's theorem.
Mr. Frizzle.
All right, ready?
Maybe for you to solve that equation,
Huh?
Maybe for you to solve that equation.
Got
Wow,
there.
that's totally not what I just said.
Got there. I don't have quite that much, but I'll get there. All right, ready? Ready? So, friends, what do you think? What do you think we should plug in here? What do you think?
Have you been investing in Bitcoin?
No.
We should plug in. You know what? Let's do the equation on the right. I think that one looks.
All right, so you want to take this,
Yeah.
and where do you want to plug that?
I want to plug that in next.
Next to the 4. You want to plug it in right there? I like it. Good job.
I know. I didn't know that was that cool either.
All right. Hey, what used to be inside those parentheses? What was there?
Right.
No, what was there originally?
4.
What was there?
X. Y.
Y. Y was there. Now we're going to replace the y with 4x plus 11. All right, here we go. Distribute. These are like terms, agree? I believe that's 13. I might be wrong with my math.
Subtract 18 from both sides.
Close. I want an x by itself, though.
Oh,
I want this by...
13.
Before that.
Subtract 44.
Yeah, subtract the 44.
That's what I was making.
All right, so 13x equals... Oh, shoot, if we had a calculator, gosh, we could do this.
It's negative 26.
Negative 26. Oh, this one's going to work out really nicely because when I divide each side by 13, what do I get? Negative 2. Yeah, baby.
How's your night going, Stuart?
I think it's good. All right, ready? Let's, what should we do with this -2, friends? Plug it in for what letter?
X.
So I could plug it in here, or I could plug it in here. They're both going to give me the same answer. Which one looks simpler? The first one. Remember, we're working smarter, not working harder. Okay, so in those parentheses is where X used to live. What's going to go there now?
-2.
-2. All right. Oh, 4 times -2. Oh, I forgot. Some costs $8. You got $11 in your pocket, so now you have $3.
Oh. Oh, done.
Giddy up, friends. I don't know about y'all, but I'm starting to feel really good about this stuff. I'm going to get, you know what, this test, I'm going for the highest grade ever. I'm going for a 78%.
Dang, Mrs.
I'll get there.
Snow signs. City, I swear. I know the snow button. It's no longer funny.
All right. Hey, remember I said we want to work smarter,
Not harder.
not harder?
Yeah.
So before, we are indeed going to substitute something in. But I want you to look at number 6. I want you to look at the equation that's on the left side. You still with me? What do all 3 of those terms on the left side equation have in common? 2. Hey, watch this. What would happen if I did this before I substituted?
No.
And I get this. Is that a little simpler?
Yeah.
Remember, we're working smarter, not harder, right? It's like, dude, you can do that? Yeah. The reason I was able to do that is I realized that 2, 2, and 2 were there on that equation. Agree?
Technically, one of them's.
All right.
You still have the candy cane from yesterday?
All right.
Wow.
What should I do with what I just circled?
You should definitely plug it in to something.
For Y next to the -2.
I'm going to plug it in right there.
I'm sorry, Stuart.
All right, friends. All right, friends. Notice where those parentheses were is where Y used to live. But notice I carried something along with this problem. I carried the negative down. Agree?
Yeah.
So that's important. If you forgot to carry that down, you're going to make an error. Okay? So now I'm just going to distribute the negative over the parentheses. Agree? These are like terms. Yeah, we're going to get a fraction, but it'll be okay. I think we'll survive.
No.
Add 2, agree? Divide by 6. Hey, what's 3 over 6 reduced to? 1/2. Yeah, it's not like 15/17 or something crazy. So we have a 1/2 value. So right here, this is one that we definitely don't want to graph. Agree? Because I got a 1/2 for one part of it. All right, so my friends, I need to take this 1/2. I need to take this 1/2.
No.
And I need to replace it either here or here
Do it.
or here.
Do it on the X minus Y equals 1.
We could.
Smart enough. Harder. Or wait, no.
Okay.
Do it. Yeah.
We could. But what letter am I looking for? Y. So if you plug it into a location, I like this equation better to plug it in. Though our answer is the same on both, this one's already given us Y equals. So I get Y equals -5, parentheses, plus 2. X used to live where those parentheses is at. What's going to go there? 1/2. Okay? And I'm not going to panic with fractions. I'm going to realize -5 times 1/2 is -5 over 2 plus 2. Hey, friends, we all realize we don't like fractions, right? So can we clear the denominator and solve it? Let's do it. Let's clear that denominator. going to multiply this by 2, this by 2, this by 2. Those cancel. Watch what's going to happen here. Agree? So what's my answer? Look at that. I just did that problem without having to worry about any fractions. Lots of chit chat. We doing all right? We talking about math?
No, absolutely not.
Okay.
They're talking about the math.
May I move on to number 7?
Yes.
We're good? Number 7. And this is actually the last one I'm going to do for today. Is that okay? All right. Friends, do I have a letter I have solved for already? Or do I have a letter, 2 letters on the same side on each? So could I modify that first equation and go, what happens if I do this and this? And I get this. Do you think that's a okay move to do? Now do I have a letter I've solved for? What should I do with y minus 3? Should I plug it in? Should I plug it into the original one right above it? Or should I plug it into the other one? Yeah, if you plug it into the one above, you're going to wind up getting an infinite solution. And that's not the answer. So be cautious. If you modify an equation to get a letter by itself, make sure you plug what that letter is equal to into the other equation. All right, so I get 3y plus 4. This was a parentheses. What was there originally in the above equation? What was there? What was here? X. What's going to go there now? Y minus 3. We are going to distribute. All right. Combine some like terms. That's like so 7y. Add 12. Oh, this one worked out nicely, didn't it? 7y equals 7. So y is equal to what, friends? 1. What should I do with this y value? Plug it in. I'm going to take this 1, and I'm going to plug it in either here, or here, or here. Which one looks easiest? First one blue or first one red? Red. What letter am I looking for? X. Notice the red equation below the blue. It's x equals. Agree? So I'm going to take this 1 and I'm going to plug it right in there. Which that gives me -2. Done. All right. So my friends, I have a question. What if we worked out we had a long problem, and x and y go away, and we wind up getting like 7 equals 7. What can you tell me about the solution in that case? Yeah, this would be infinite solutions. Okay, same idea. What would happen if I'd solved it and I wind up getting 7 equals 8?
No solution.
No solution. No solution graphed are what kind of lines? Parallel. Infinite solution means that if I graphed it, they lie right on top of each other. Okay? Sound like a deal? We feeling okay, friends? Yeah, baby. All right.
What's the homework?
We'll figure something out. What do you feel like? You guys want a lot of homework tonight?
No, I feel like we have nothing.
I think you don't give us any.
All right. Page 207 and 208 all.
All just do ours. Just do ours.
Oh,
This is so much work.
What'd you notice about 208?
Especially 208.